Master PyTorch to ONNX conversion for cross-platform AI. Learn how to convert PyTorch models to ONNX for seamless cross-platform integration, equipping you with skills for AI model deployment across diverse frameworks.
Did you know that converting your PyTorch models to ONNX can unlock a world of cross-platform AI possibilities? Welcome to our deep dive into mastering this essential skill. Today, we'll take you through the entire process of converting PyTorch models to ONNX format, ensuring you can deploy your AI models across multiple frameworks seamlessly. With ONNX, the Open Neural Network Exchange, you can achieve broader compatibility and enhanced integration. Stick around to become proficient in this critical aspect of AI development. Why should you consider using ONNX for your PyTorch models? The answer lies in interoperability and flexibility. ONNX serves as a bridge, allowing PyTorch models to operate across various platforms and frameworks without the typical compatibility headaches. By converting to ONNX, you gain a framework-agnostic format that simplifies model deployment, be it on a cloud service, mobile device, or edge computing environment. Furthermore, ONNX reduces dependency issues, as it abstracts your model from the specific intricacies of PyTorch, enabling more scalable AI solutions. Whether you're a developer, data scientist, or AI engineer, mastering ONNX conversion can significantly streamline your workflow, making your models more versatile and future-proof. Before you can convert your PyTorch model to ONNX, you need to ensure it's ready for export. Start by reviewing your model's architecture to identify any operations or layers that aren't supported by ONNX. This might require replacing or re-implementing certain functions. Next, verify that your model's input and output formats match the expectations for ONNX conversion. This often involves confirming the shape and data types of tensors. It's also a good idea to set up a clean Python environment to avoid conflicts with libraries or dependencies. Run pre-export checks, such as verifying that your model performs correctly on test data, to catch any potential issues early. This preparation phase is crucial for a smooth conversion process.
To convert PyTorch models to ONNX, you need the right tools. Start by ensuring you have the latest versions of PyTorch and the ONNX library. Use pip to install these packages. Pip install torch ONNX. It's crucial to check the compatibility between PyTorch and ONNX versions, as mismatches can lead to conversion errors. If you encounter installation issues, such as permission errors or version conflicts, consider using a virtual environment like Venv or Conda to manage dependencies cleanly. Following best practices for environment setup can save you time and headache, ensuring that your tools are ready for seamless conversion.
Let's dive into the conversion process itself. The primary function you'll use is torch.onx.export, which requires your PyTorch model and a sample input tensor. Define the input shapes explicitly to guide the conversion, especially if your model uses dynamic input sizes. Handle dynamic axes by specifying them in the dynamic_axes parameter, allowing more flexibility in input dimensions. If your model includes custom operations not natively supported by ONNX, you'll need to implement these as custom ops. Finally, save the resulting ONNX model to a file with an appropriate extension, such as .onx. This step is crucial for ensuring that your model is ready for deployment across platforms.
Conversion doesn't always go smoothly. Common issues include export errors, often due to incompatible operations or incorrect input shapes. Shape mismatches can arise if the input tensor shapes aren't accurately defined or if the model expects a specific batch size. Unsupported operations require custom implementations or substitutions with equivalent ONNX-compatible layers. Utilize ONNX tools like onnnx.checker to debug and validate your model, ensuring it meets the ONNX standards. Familiarize yourself with common pitfalls, such as precision loss or optimization challenges, and know how to address them to streamline your conversion process.
After conversion, it's vital to verify the accuracy and reliability of your ONNX model. Start by comparing the outputs of your PyTorch and ONNX models using the same test data. Minor differences in outputs can occur due to precision variations, however, significant discrepancies may indicate conversion errors. Use ONNX runtime to validate your model's functionality and performance. It's a powerful tool for running ONNX models and ensures they perform as expected. Ensure functional equivalence by thoroughly testing your model across various inputs, confirming that it maintains the desired accuracy and efficiency post-conversion. With your ONNX model ready, it's time to deploy it. ONNX models can be seamlessly integrated into various platforms, offering flexibility in deployment. For cloud services, platforms like AWS SageMaker and Azure Machine Learning provide robust environments for deploying ONNX models. For edge or mobile deployment, consider using ONNX runtime with optimizations for the specific device constraints, such as reduced memory or processing power. The framework compatibility of ONNX allows easy integration with applications developed in different environments, enhancing the reach and usability of your AI solutions. Leverage the advantages that ONNX brings to find the best deployment strategy for your needs. To maximize the performance of your ONNX models, consider advanced optimization techniques. Quantization can significantly reduce the model size and improve inference speed by converting weights and activations from floating point to integer representations. Graph simplification strategies, such as removing redundant nodes or merging operations, can streamline your model's execution path. ONNX offers tools like ONNX Optimizer for performance tuning, helping you find the right balance between accuracy and speed. Understanding these optimization techniques will allow you to deploy more efficient AI models without compromising on the quality or precision of your predictions. Congratulations! You've now mastered the art of converting PyTorch models to ONNX, opening up new possibilities for cross-platform AI deployment. We've covered everything from preparing your model, executing the conversion, to overcoming common challenges. ONNX is a powerful tool in modern AI, offering unparalleled flexibility and integration potential. We encourage you to practice these skills and explore further optimization techniques. Share your experiences in the comments below, and let us know what topics you'd like us to cover next. Don't forget to subscribe for more insights into the world of AI.